Hello all. Good morning. Welcome to an academy. Let's crack it. Crack GATE and ESC with India's largest learning platform. GATE Plus subscription and access unlimited live and recorded courses from India's best educators. Before going to start this, let me introduce myself. Myself Anashri Palasdevkar. I completed my MSc in mathematics from Mumbai University and also having 13 plus years of teaching experience. I mentored more than 10,000 plus students for the engineering. Now, here is an Academy's learning app. How to install the Academy's learning app. Now, what you will get on an Unacademy's platform? You will get daily live classes. In this, chat with your educator, engage in discussions, ask your doubts and answer polls all while the class is going on. Live test and quizzes, you will get evaluate your preparation with our regular mock test and quizzes and get detailed analysis on your performance. Now you will get structured courses. All our courses are structured in a line with your exam syllabus to help you the best prepare for it. Now here is unlimited access you will get. One subscription gets you access to all our live and recorded courses to watch from the comfort of any of your devices. Now iconic subscription, you will get a personal coach in this iconic subscription. So get one-on-one guidance from the top exam experts as your personal coach. Align your preparation strategy and learning resources. Mains question and answer practice is there. Strengthen your mains answer writing through the regular practice with evaluation and personalized feedback. Now you will get study tracker, participate in a study tracker plan and study booster workshops. Evaluate your progress in by weekly reviews with the personal coach. Now you will get all benefits of Plus in this iconic subscription. So live classes from the top educators, mock test and quizzes, structured batch courses in line with exam syllabus. Now Plus subscription. So you will get a Plus subscription in the what you will get a daily live classes in the same, chat with your educator, engage in discussions, ask your doubts and answer polls while class is going on. Now live test and quizzes, evaluate your preparation with our regular mock test and quizzes and get detailed analysis on your performance. Structured courses, all our courses are structured in a line with your exam syllabus to help you the best prepare for it. Now unlimited access you will get. One subscription gets you access to all our live and recorded courses to watch from the comfort of any of your devices. Now learn with the top educators of Unacademy. Now these are the some top educators of Unacademy. Now these are also some top educators of Unacademy. Now GATE and ESC. Here you can see GATE and ESC courses. The batches for each and every branch of engineering you will get different courses are available here. Now for the Plus subscription, you will get India's best educators, interactive live classes, structured courses and PDFs, live tests and quizzes. Now you will get all the benefits of Plus in iconic subscription. All the benefits of Plus you will get in iconic subscription and use personal, see in this iconic subscription you will get personal coach, personalized test analysis, study planner and preparatory study material also you will get. Now if you are going to prepare for the GATE and ESC, you can take any subscription plan either for Plus subscription or for iconic subscription. The Plus subscription plan cost you for rupees 30,250 for 12 months. Now this will cost you 27,225. If you use my promo code DSP, you will get a 10% discount on it. Now iconic subscription the same. In this subscription you will get a 12-month subscription plan for 50,250. But if you are going to use my promo code DSP, you will get a 10% discount. The same plan it will cost you for 45,225. Now batch C, evolve for the GATE 2022 for the civil engineering. New batch alert is already started from the 25th of January 2021. Now to get the 10% discount and to enroll in this batch, you can use my promo code DSP. Now batch C, Ascent for GATE 2023 for civil engineering. New batch alert, it is already started from 25th of January from 2021. To enroll in this batch, you can use my promo code DSP to get the 10% discount. Now new batch alert for the batch A. For the chemical engineering, the batch is already started from 25th of January, right? And to enroll in this batch, you can use my promo code DSP. Now assign for the GATE 2023 for the mechanical engineering batch C is already started from 25th of January. So to enroll in this batch, you can use my promo code DSP to get the 10% discount. Okay. Now Sparks new batch alert is here. Now this new batch is started from the today itself. Okay, you can to enroll in this batch, you can use my promo code DSP to get the 10% discount. And this batch is only for the English batches. Now ascend for the GATE 2023 for mechanical engineering batch E will be also start from today itself. To enroll in this batch, you can use my promo code DSP to get the 10% discount. Now to evolve for the batch E GATE 2022 for mechanical engineering. To enroll in this batch, you can use my promo code DSP to get the 10% discount. Now batch C is already, that will be start from today itself. So to enroll in this batch, you can use my promo code DSP to get the 10% discount in it. Okay, now let's start our main topic, that is limit of a sequence. What do you mean by limit of a sequence? How it is works, and what is the value of how to find out the value of the limit? We will see the definitions and different tests of convergence in this. Now see what you mean by limit. If the value of the large number of terms given in a given sequence are approaches to a finite term, say L, then L is called as limit of a sequence. Suppose consider the sequence. Okay. Consider a sequence. You can see here 1, 1 by 2, 1 by 3, 1 by 4 and so on. Okay, this is your sequence. Now whenever your number of this denominator it goes on increasing, the value of this sequence as n tending to infinity becomes 1. Right? So here the large number of terms here approaching to 0. If you see here, the large number of terms will be approaching to 0. It means, suppose this is your interval, and if you are taking from the 1 to 2, suppose. So the 1 to 2, it is 1 by 2, 1 by 2 upon 2, that is 1 by 4 is here. So ultimately it is approaches to 0. Right? So these terms are approaches to 0. So whenever the number of terms are approaching to 0, therefore the limit of the sequence is 0. Now limit of this sequence is 0. Why? Because it is nothing but the general last term of the sequence is 1 upon n, and whenever n approaches to infinity, it means whenever n tends to infinity, this limiting value of this sequence becomes 0. Right? Limit as n tending to infinity, 1 upon n is equal to 0. So the limiting value for this sequence is 0. Here large number of terms are approaching to 0. Therefore limit of the sequence is 0. If epsilon is greater than 0, see the definition in this form we can write down. If epsilon greater than 0, there exists some n belongs to n such that mod of n minus L is less than epsilon for all n greater than n. For all n greater than n. So for all n greater than n, mod of n minus L is less than epsilon. Okay, so we can see that well, definition of a limit here. For any epsilon greater than 0, you can give you any epsilon greater than 0. There exists n belongs to n such that mod of n minus L is less than epsilon for all n belongs to n. Okay, so you will get it here. For all n belongs to n, mod of, for any epsilon greater than 0, there exists n in n such that mod of n minus L is less than epsilon for all n belongs all n greater than n. Okay, in then L is called as limit of a sequence. Then L is called as limit of a sequence. Okay? Then L is called as limit of a sequence, and we can write this as limit as n tending to infinity of n is equal to L. Okay? In this way, we can write the definition of a limit. Now, right? Now we'll see convergence of a sequence. Okay, when we say that the sequence is convergent. In this case, see, if limit L of a sequence is finite, sequence Sn is finite, then Sn is said to be convergent. It means limit as n tending to infinity, Sn is equal to finite, then we say that it is convergent. For example, suppose that limit as n tending to infinity, right? Suppose limit as n tending to infinity, n is equal to 1 upon n, which is equal to 0. Hmm? So limit as n tending to infinity, where n is equal to 1 upon n. So limit as n tending to infinity is 0, which is finite. Therefore, this sequence is convergent. Okay. Now, suppose on the limit, suppose limit as n tending to infinity, n is equal to n is equal to infinity, then we say that the sequence is divergent. Okay. You can take any sequence, suppose n is equal to 3 by n plus 5. So limit as n tending to infinity. Limit as n tending to infinity, n is equal to 3 upon infinity plus 5, which is equal to 5. Finite. Therefore, sequence is convergent. Yeah. Therefore, the sequence is convergent. Now, we say that if a geometric series, see, a geometric series summation n varying from 1 to infinity ar raised to n converges if r is less than 1 and diverges if r is greater than or equal to 1. If the limit is finite and it is less than 1, then definitely the given geometric series is convergent. And if limit is finite and greater than 1, greater than or equal to 1, then the sequence is divergent. Okay. Now, P-series test. What do you mean by P-series test? A series of the form 1 upon 1 raised to P, 1 upon 2 raised to P, plus 1 upon 3 raised to P, plus and so on is equal to summation n varying from 1 to infinity 1 upon n raised to P is called a P-series or P-series test. By P-series test, the given sequence is convergent if P is greater than 1 and divergent if P is less than or equal to 1. Right? So given series is convergent by P series test if P is greater than 1 and divergent if P is less than or equal to 1. Okay? No. We'll say that comparison test. What do you mean by comparison test? Let summation n varying from 1 to infinity un be a given series, and if un of the form say un is equal to p1 upon n upon p2 upon n, where p1 of n and p2 of n are algebraic polynomials in n, then we apply comparison test. Okay, so then we'll apply comparison test. Now, so how it works, the comparison test? Now, we will see the procedure. Consider an auxiliary series. Consider an auxiliary series summation n varying from 1 to infinity Vn where Vn is equal to n raised to p upon n raised to q is equal to 1 upon n raised to q minus p, right? N raised to p upon n raised to q, where Vn is equal to n raised to p upon n raised to q. So 1 upon n raised to q minus p. Here n raised to p and n raised to q are the terms with the maximum power of numerator. It means n raised to p is the term with the maximum power of numerator. N raised to q is the term with the maximum power of denominator. So if limit as n tending to infinity, see, limit as n tending to infinity is finite and non-zero, then summation n varying from 1 to infinity un and summation n varying from 1 to infinity vn behaves like. That is, both the series are either convergent, or divergent simultaneously. And the nature of the series is determined by P series test. Is determined by P series test. If n raised to p upon n raised to q is finite and non-zero, then summation n varying from 1 to infinity un and summation n varying from 1 to infinity vn behaves like. Both the series are either convergent or divergent simultaneously, and the nature of the series is determined by the P series test. Okay. Now we will see some examples. Now test the convergence of the following series. Question number 1. Test the convergence of the following series. 2 by 1 plus 3 by 8 plus 4 by 27 plus 5 by 64 plus and so on plus n plus 1 upon n cube. So here un is equal to n plus 1 upon n cube. If you see the nth term of this series, so un is equal to n plus 1 upon n cube. Since there is a polynomial in numerator and polynomial in denominator with the nth term of the given series, so we apply the comparison test. Okay, so how we can find out Vn? So highest power of n here in the numerator is n. Highest power of n here is n cube. So 1 n upon n cube, 1 upon n square is here, right? So we will get here 1 upon n square. Now consider, by comparison test, we'll consider limit as n tending to infinity, un upon vn is equal to limit as n tending to infinity, n plus 1 upon n cube upon 1 upon n square, which is equal to limit as n tending to infinity. Here n plus 1 upon, now see n cube and n square will get cancelled out. So we will get here 1 upon n, right? So limit as n tending to infinity. Here n into n plus 1. So you will get n plus 1 upon n is same as limit as n tending to infinity 1 plus 1 upon n, which is limit as n tending to infinity is 0. So 1 plus 0 is 1, which is finite and non-zero. Which is finite and non-zero term. Okay, so by comparison test, we'll see. By comparison test, both the series are either convergent or divergent simultaneously. Now we can see the summation of Vn. Summation n varying from 1 to infinity Vn is equal to summation n varying from 1 to infinity 1 upon n square is convergent by P series test. As why it is convergent? Because P is what? Here P is equal to 2, which is greater than 1. If P is greater than 1, the given series is convergent, and therefore the given series is also convergent. Therefore, the given series also convergent. Okay? Therefore, the given series is also convergent. Now we'll see the next example. Here, test the convergence of the following series. Okay. Test the convergence of the following series. Test the convergence of the following series. The series is given 1 upon 2 into root 1 plus 1 upon 3 into root 2 plus 1 upon 4 into root 3 plus and so on plus 1 upon n plus 1 into root n. 1 upon n plus 1 into root n. Okay. Now आपको क्या दिख रहा है यहाँ पे? So 1 upon 2 root 1, 1 upon 3 root 2 plus 1 upon 4 root 3 and so on 1 upon n plus 1 into root n. So we will write down this series in the form of un upon vn. Right? So how we can write down here? How we can write down here un upon vn? So you will get un is equal to, if you observe, see the terms in the root is n and terms of the outroot is n plus 1, or in other way, if you say this is n, then this is n minus 1. Anyway you can use. So you'll get un is equal to 1 upon n plus 1 into root n, right? 1 upon n plus 1 into root n. Therefore, n term of the auxiliary series Vnb. Therefore, nth term of auxiliary series Vnb. So, Vn is equal to 1 upon n into root n. Right? Now, consider here. What we have to consider, limit as n tending to infinity, un upon Vn is equal to limit as n tending to infinity 1 upon n plus 1 into root n upon 1 upon n into root n, right? So if you see, it is equal to limit as n tending to infinity 1 upon n plus 1 into root n into n into root n, right? If you observe root n get cancel out. This root n and root n get cancel out. So you will get limit as n tending to infinity, here n upon n plus 1. Right? Limit as n tending to infinity n upon n plus 1. So we can write this same as limit as n tending to infinity 1 upon 1 plus 1 by n. So limit as n tending to infinity, you will get here 1, because 1 upon infinity is 0 and is equal to 1, which is finite, and non-zero. Finite and non-zero. Therefore, here both the series, which one? Un and Vn. are either convergent or divergent simultaneously. But summation n varying from 1 to infinity Vn is equal to summation n varying from 1 to because the nature of the series is depending upon Vn, right? So summation n varying from 1 to infinity Vn, summation n varying from 1 to infinity. What is your Vn? Vn is n into root n, which is equal to 1 upon n raised to 3 by 2, 1 by 2 plus 1. So 3 by 2 is convergent by P series test. Why? Because P is equal to 3 by 2 and 3 by 2 is greater than 1. Okay, is convergent by P series test. Okay, so therefore summation n varying from 1 to infinity Vn is convergent. Therefore given series summation n varying from 1 to infinity Un is also convergent. Right? Now next. Now I hope you are getting it clearly how to use the P series test and how to apply the comparison test. Okay. Now let's see our new test for the series. Ratio test, which is many times we will use. The third one is ratio test. Okay, we'll use the different color. Yeah. Ratio test. What the test says? If Un contains the terms of the form, if Un contains terms of the form, first one, a raised to n is of the form a raised to n, where a is constant. If Un contains a raised to n, where a is constant. Second, n factorial, that is a factorial term. Third one, continuous product. Fourth one, n raised to n, etc. Then we apply the ratio test. Now see, when we apply the ratio test, if Un contains the terms of the form a raised to n, where a is any constant like 2 raised to n, 3 raised to n, 4 raised to n, 5 raised to n, anything. And if it contains n factorial, suppose 2 factorial, 3 factorial, 5 factorial, or continuous product, it means n into n plus 1, n plus 2, n plus 3, and so on, or n raised to n form, then we apply the ratio test. Okay, so in this ratio test, what we will do, see the procedure, how we apply the ratio test. Now here this says that when we apply the ratio test. Now we'll see how we apply the ratio test. Okay, suppose let here summation n varying from 1 to infinity Un be given series. So Un, which implies Un is nth term. Un is nth term. Un plus 1 n plus first term, which is obtained by changing each n, which is obtained by changing each n of Un each n of un to n plus 1. Okay, so let limit as n tending to infinity un upon un plus 1 is equal to L, say, right? Then the series, see, this is very important part, then the series summation un n varying from 1 to infinity is first one convergent. The series is convergent if L is greater than 1. Second is divergent if L is less than 1. Third one, test fails if L is equal to 1. Okay, then we will say that the series summation un n varying from 1 to infinity is convergent if L is greater than 1, is divergent if L is less than 1, and test fails if L is equal to 1. Okay, now this is the main important thing of the ratio test. Now, are you clear it? When we apply the ratio test, if un contains the terms of the form a raised to n where a is a constant, or it contains n factorial, or it contains a continuous product, or it contains n raised to n terms, then we say that the ratio test is applicable to that series. Okay, and how it is applied? Now see, let un be a given series. Un is the nth term and un plus 1 n plus first term, which is obtained by changing each n to un to n plus 1. Okay, how you will get un plus 1 with the help of un? Just replace n by n plus 1. And let un upon un plus 1, whatever ratio is, you will get, that is L. Now, if the ratio L is greater than 1, the series is convergent, and if it is less than 1, then its series is divergent, and if it is equal to 1, then test fails. It means further investigation is required. Okay, now let's see one example. Test the convergence of the series whose nth term is given by whose nth term is given by n factorial upon n raised to n, is given by n factorial upon n raised to n, which implies un is equal to n factorial upon n raised to n. N term is given. Now what is your procedure? We can find out un plus 1. Okay, so how you will get un plus 1? So replace by n by n plus 1. So we apply the ratio test. Why we apply the ratio test? Now your un contains a factorial term as well as n raised to n terms. So definitely we will apply the ratio test as per our ratio test. See, it contains n raised to n terms and n factorial also. Then we apply the ratio test. Now see, un upon n factorial upon n raised to n. Okay, now we will calculate by ratio test here un plus 1. By ratio test we get un plus 1 is equal to n plus 1 factorial upon n plus 1 raised to n plus 1. N plus 1 factorial upon n plus 1 raised to n plus 1. Now consider here un upon un plus 1 is equal to, what is your un? N factorial upon n raised to n. Right, now un plus 1, so un plus 1 is n plus 1 factorial upon n raised to n plus 1 raised to n plus 1. right? So we can multiply and write down here n plus 1 bracket raised to n plus 1 upon n plus 1 factorial. Yeah, so you will get here n factorial upon n raised to n into, here you will get n raised to n or n plus 1 raised to n plus 1 into n plus 1 raised to n upon, we will get n plus 1 factorial. So can I write this as n plus 1 factorial? It means 2 factorial. We can write 2 into 1 n minus 1. So you will get here n plus 1 into n factorial, right? So if you observe, this n plus 1 and this n plus 1 get cancelled out. This n factorial will get cancelled out. So we will get limit as n tending to infinity, right? So only we will see here un upon un plus 1. So here n plus 1 bracket raised to n upon n raised to n. Now if you observe here n raised to n, you can calculate, take n common. So 1 upon n bracket raised to n upon n raised to n, right? So this n limit n raised to n get cancelled out. Now we will apply the limit as n tending to infinity, right? We require to find out limit as n tending to infinity. Now here is limit as n tending to infinity. Limit as n tending to infinity, you will get, so this is 1 plus, this is the standard formula of limit as n tending to infinity, 1 plus 1 by n bracket raised to n is equal to e, where e is greater than 1. So by ratio test, the given series is, here by the ratio test, the given series is convergent. Therefore, by ratio test, given series is convergent. Therefore, by ratio test, the given series is convergent. Okay. Now, second one you can see. Now we'll see one more example. Now test the convergence of the following series, whose nth term is given by. Test the convergence. Test the convergence of the following series. Of the following series, whose nth term is given by. Whose nth term is given by un is equal to n cube upon 3 raised to n. Okay, whose nth term is given by n cube upon 3 raised to n, which implies un is equal to n cube upon 3 raised to n, right? So consider, by ratio test, we will consider un upon un plus 1 and then take the limit as n tending to infinity, right? So what is your un? Un is n raised to 3 upon 3 raised to n. Upon un plus 1, it means into 3 raised to n plus 1 upon n plus 1 bracket cube, right? So we will take un upon un plus 1 is equal to n cube upon 3 raised to n into, you will get 3 plus 3 raised to n plus 1. So can I write this as 3 raised to n into 3 raised to 1 upon n plus 1 bracket cube. So take n common. So you will get n cube plus, so n plus 1 bracket cube. We can write as it is here, n plus 1 bracket cube. So here 3 raised to n, 3 raised to n can cancel out. You will get n cube into 3 upon n plus 1 bracket cube. Now if I take the n cube into 3 upon, take n common. So it comes with the index. So n cube into bracket 1 plus 1 by n raised to 3. Right? So this n cube and this n cube will get cancelled out, right? This n cube and this n cube will get cancelled out. So we will get limit as a un upon un plus 1 is equal to 3 upon 1 plus 1 by n bracket raised to 3, right? Now take the limit. Limit as n tending to infinity. Limit as n tending to infinity, un upon un plus 1 is equal to 3 upon 1 plus 1 by n bracket raised to 3 is same as, now limit as n tending to infinity, this 1 upon infinity is 0, 1 raised to 3 is 3, so which is equal to 3. And by ratio test, here limit L is finite and greater than 1. So definitely this series is convergent by ratio test. By ratio test, therefore, we can write by ratio test, given series is convergent. Right? By ratio test, given series is convergent. Now, see, we will see here one more example, very interesting example. Now, third example. Test the convergent. Test the convergence of the following series. Of the following series whose nth term is given by summation n varying from 1 to infinity 2 into 4 into 6 and so on up to 2n upon 5 into 8 into 11 into so on 3n plus 2, right? Summation n varying from 1 to infinity 2 into 4 into 6 and so on up to 2n, 5 into 8 into 11 into so on into 3n plus 2, right? So we will get here. Now find a solution for this. Now if you observe the first term for this series, you will get here 2 by 5, right? Plus 2 into 4 upon 5 into 8 plus 2 into 4 into 6 upon 5 into 8 into 11 plus and so on. You will get 2 into 4 into 6 into 8 and so on up to 2n upon 5 into 8 into 11 and so on 3n plus 2, right? Now here un, you will get un is equal to, what is your un? Un is 2 into 4 into 6 into 8 and so on up to 2n divided by 5 into 8 into 11 into 14 into so on 3n plus 2. Here. Now what you will get un plus 1. So you will get un plus 1 as 2 into 4 into 6 into 8 and so on 2 into n plus 1, right? So 5 into 8 into 11 into 14 into so on into bracket 3 into n plus 1 plus 2, right? Just replace n by n plus 1. So we'll get un and un plus 1. Now we'll consider why we are using ratio test here. Why we are using ratio test here? Because it contains the series, the sequence in the form of n upon n raised to n or n upon n form. Okay. So consider here un upon un plus 1, which is equal to 2 into 4 into 6 and so on up to 2n upon 5 into 8 into 11 and so on up to 3n plus 2. multiplied by 5 into 8 into 11, 3n plus 2 into 3n plus 5 divided by 2 into 4 into 6 and so on, 2n into 2n plus 2. So which is equal to 3n plus 5 upon 2n plus 2. Right? 3n plus 5 upon 2n plus 2. No. So limit as n tending to infinity, un upon un plus 1. You will get limit as n tending to infinity, 3n plus 5 upon 2n plus 2. 3n plus 5 upon 2n plus 2. Now take here limit as n tending to infinity n common. So n into bracket 3 plus 5 by n upon n into bracket 2 plus 2 by n. Now limit as n tending to infinity. Now this n get cancel out. Once you put the limit as n tending to infinity, 5 by n tends to 0 and 2 by n tends to 0. So you will get ultimately the limiting value for this is 3 by 2 and 3 by 2 is greater than 1. So by ratio test the given series is convergent. So by ratio test, therefore by ratio test given series is convergent. Given series is convergent. Okay. Now let's see the next example. Fourth example, test the convergence of the series. Test the convergence of the series summation n varying from 1 to infinity 2 raised to n into n factorial upon n raised to n. Right? So this is your un. Let's see. See the term content here raised to n raised to n. So which test is applicable? See all the terms are here. A raised to n raised to n factorial. So definitely we will apply here ratio test. Okay. So let un is equal to 2 raised to n into n factorial upon n raised to n. Okay. So what you will get un plus 1. So un plus 1 is 2 raised to n plus 1 into n plus 1 factorial upon n plus 1 raised to n plus 1. Right? So un upon un plus 1 is equal to 2 raised to n into n factorial upon n raised to n into n plus 1 bracket raised to n plus 1 upon 2 raised to n plus 1 into n plus 1 factorial. Right? So now take 2 raised to n into n factorial upon n raised to n into n raised to n plus 1 into n plus 1 bracket raised to n upon 2 raised to n into 2 into n plus 1 into n factorial. Right? So we'll get n plus 1 can cancel out, n plus 1 cancel out. This n factorial get cancel out. This 2 raised to n, this 2 raised to n get cancel out. So you will get here n plus 1 bracket raised to n upon n raised to n into 2. Right? So what we will do, we will find out n raised to n common. So 1 plus 1 upon n bracket raised to n upon n raised to n into 2. Now this will get cancelled out. Now we will take the limits on both sides. Okay. So limit as n tending to infinity, un upon un plus 1 is equal to limit as n tending to infinity, 1 plus 1 upon n bracket raised to n upon 2. Right? So you will get 1 by 2 into, what is the standard formula for this? This is E. And we know that the value of E is what? 1 by 2 into value of E is 2.71383 upon 2. So you will get 1.3591, which is greater than 1. So by ratio test, given series is convergent. By ratio test, given series is convergent. Okay. By ratio test, given series is convergent. Now we'll see the RAPS test. Okay. Okay. Fourth test, that is RAPS test. RAPS test. Okay. When we apply the RAPS test, generally if the ratio test fails, then we'll use RAPS test. Okay. Generally, if ratio test fails, we use RAPS test. Okay. Generally when ratio test fails, then we use RAPS test. Okay. We know that the ratio test, why? If it is greater than 1 or less than 1. If it is greater than 1, then by ratio test the given series is convergent. If it is less than 1, then the ratio test, by ratio test the given series is divergent. And if it is equal to 1, then we require the further investigation. Okay. Then only apply we will use, then only we can apply RAPS test. When the limit of the sequence is equal to 1 by using ratio test, then at that time we will apply the RAPS test to test the convergence of the series. Okay. Now when we apply, now how to apply, that we'll see. Let's suppose limit as n tending to infinity, un upon un plus 1 is equal to 1. So therefore, limit as n tending to infinity, n into bracket un upon un plus 1 minus 1, which is equal to L. So then summation n varying from 1 to infinity un is, first one, convergent if L is greater than 1, second, divergent if L is less than 1, and third one, test fails if L is equal to 1. Okay. Convergent if L is greater than 1, divergent if L is less than 1, and third one, test fails if L is equal to 1. Clear? Now this is our ratio test. Now we'll see. This is our RAPS test. Now first we'll see one example. Okay. Test the convergence of the series 1 upon 2 into 4 plus 1 upon 1 into 3 upon 2 into 4 into 6 plus 1 into 3 into 5 upon 2 into 4 into 6 into 8 plus and so on. Okay. So with the help of this, first we will find out nth term and then n plus 1th term. Okay. So write down. So what we will get un here? So we'll get un is 1 into 3 into 5 into 7 into and so on. Is it nothing but 2n minus 1? Right? Similarly, 2 into 4 into 6 into 8 and so on, you will get it is 2n. Yeah. So 2n minus 1 upon 2n. Now un plus 1. So if you observe here, the previous term is 2n minus 3 and here is previous term is 2n minus 2. Right? So we can find out un plus 1. So what is here un plus 1? un plus 1 is 1 into 3 into 5 into 7 and so on. 2 into bracket n plus 1 minus 1 upon 2 into 4 into 6 into 8 and so on up to 2n plus 1. Right? Now we'll see un upon un plus 1. Okay, we'll get un upon un plus 1. So what is our un? 1 into 3 into 5, 1 into 3 into 5 into 7 and so on up to 2n minus 1 upon here is 2 into 4 into 6 up to 2n, right? Into what is your un plus 1? Un plus 1 is this. So upon un plus 1, so shall I write this numerator as denominator and denominator as a numerator? So you will get 2 into 4 into 6 and so on up to 2n into 2n plus 2. The next term is 2n plus 2 upon here is 1 into 3 into 5 and so on 2n minus 1 into 2n plus 1, which is equal to 2n plus 2, 2n plus 2 upon 2n minus 1, right? Sorry, 2n plus 1. That is 2n plus 1, right? So, no, 2n minus 1, right? So, this is your un upon un plus 1. Now, take the limit as n tending to infinity. Limit as n tending to infinity. Limit as n tending to infinity. 2n plus 2 upon 2n minus 1, which implies limit as n tending to infinity. N common 2 plus 2n by n upon n into 2 minus 1 by n. So n get cancelled out. Limit as n tending to infinity. So 2 by 2, which is equal to 1. Now if you observe the limit as n tending to infinity, un upon un plus 1 is equal to 1. Limit as n tending to infinity, un upon un plus 1 is equal to 1. Therefore ratio test fails. Therefore ratio test fails. As ratio test fails, we'll get consider here un upon un plus 1 minus 1, which is equal to un minus 1. So what is your un upon un plus 1? So that is 2n plus 2 upon 2n minus 1, right? 2n minus 1 minus 1. So we'll get 2n plus 2 minus 2n plus 1 upon 2n minus 1. So we'll get plus 2n minus 2n cancel out. So 3 upon 2n minus 1. Okay. So 3 upon 2n minus 1. So therefore we get n into un upon un plus 1 minus 1, which is equal to n into 3 upon 2n minus 1, which is equal to 3n upon n into bracket 2 minus 1 upon n, which is equal to 3 upon 2 minus 1 upon n. So limit as n tending to infinity, n into un upon un plus 1 minus 1 is equal to limit as n tending to infinity 3 upon 2 minus 1 by n, which is equal to 3 by 2, which is greater than 1, right? So therefore by Raps test, given series is convergent. Therefore by Raps test, given series is convergent. Okay? No. I hope you are getting it, the Raps test. Now Cauchy's Enthrut test. we'll see. Fifth test, that is Cauchy's nth root test. Okay, now when we apply the Cauchy's test, that we'll see, and then how to apply the Cauchy's nth root test, that also we'll see. Now if power of each term in un, if power of each term in un is in the form of n, then we apply nth root test. Okay, now how to apply? Whenever it is when the test contains, or when the series or sequence contains power of n, then we will apply Cauchy's nth root test. Now how to apply? Let summation n varying from 1 to infinity un be a given series. So let limit as n tending to infinity un raised to 1 by n is equal to L. Then if L is less than 1. Now see, here is different. Generally whenever n greater than 1, we say that the series is convergent. But here, first the given series is, here first one convergent if L is less than 1. Second one divergent if L is greater than 1. Third one test fails if L is equal to 1. Right? Series is convergent if L is less than 1, divergent if L is greater than 1, and test fails if L is equal to 1. Right? So test the convergence of the series. Let's see first example. Test the convergence of the series. Convergence of the series. Summation n varying from 1 to infinity 2 raised to 3n upon 3 raised to 2n. Okay, so given here. So here series contains in powers of n. So we'll use un is equal to what? 2 raised to 3n upon 3 raised to 2n. So un raised to 1 by n, which is equal to 2 raised to 3n raised to 1 by n upon 3 raised to 2n raised to 1 by n. So which is equal to 2 raised to 3 upon 3 raised to 2. So 2 raised to, now we'll see limit as n tending to infinity n raised to un raised to 1 by n is equal to limit as n tending to infinity 2 raised to 3 upon 3 raised to 2, which is equal to 8 by 9 is less than 1. So by Cauchy's nth root test, the given series is convergent. Okay. Now let's see second example. We'll see whether the given series is convergent or divergent. Okay. So let's see, test the convergence. Test the convergence of minus n raised to 3 by 2. Now see, this is very complicated example. Now here we can find out un. What is our un? 1 plus 1 upon root n bracket raised to minus n raised to 3 by 2, right? So we will see un raised to 1 by n is equal to 1 plus root n bracket raised to minus n into 3 by 2 raised to 1 by n, right? Now if you observe, you will get un raised to 1 by n is equal to 1 plus 1 upon root n raised to minus n 1 by 2. So un raised to 1 by n is equal to 1 upon 1 plus 1 upon root n raised to root n. Limit as n tending to infinity, un raised to 1 by n is equal to limit as n tending to infinity 1 upon 1 plus 1 upon root n raised to root n is equal to 1 upon e. So 1 upon e is definitely less than 1. So by Cauchy's nth root test, the given series is convergent. By Cauchy's nth root test, given series is convergent. Okay, by Cauchy's nth root test, given series is convergent. Okay. Now, if you are in, so these are the some test of convergence. So here we have seen 5 tests of convergence, right? RAPS test, Cauchy's nth root test, then ratio test, then a p-series test, and only simply the finite test. If the series is ratio test, so here we apply. If the geometric series converges if r is less than 1 and diverges if r is greater than 1. So here we have seen 5 tests of convergence. In the next lecture, if you want, you can we will see the example, which is mixture of the example. So now you have to decide. In this lecture, what we have done? We have done that the series test, definition of a test, and how when we apply the test is given, and the type of examples we have sought. Now in the next lecture we will see any randomly example is given to you. So you have to decide which test is applicable for the given example. Okay. So if you're really liking my videos, please do like, share and subscribe, and do not forget to press the bell icon for further notification. Thank you so much.